Hello, chemistry friends. This is Mrs. McBride coming to you live from my kitchen table. Our next exciting topic in chemistry is behavior of gases. My children find it very funny that we're going to spend an entire topic talking about gas. So here we go. I've placed these notes for you on Google Classroom if you'd like to print them out and follow along, or else follow along and answer the questions as we go. So the first thing you might be saying to yourself is, what is a gas? A gas is a flowing, compressible substance with no definite volume or shape. So think about something like the difference between a solid, liquid, and a gas. So a solid has a definite volume and definite shape. Okay, if you have a rock has a definite volume and definite shape. Okay, if you have a liquid, it has a definite volume, meaning that it takes up a certain amount of space, but it definitely doesn't have a definite amount of shape. Like if you put liquid in a container, it takes the shape of its container, but it really could be any shape, okay? So let's talk about gas. Although different gases may differ widely in their chemical properties, they share many of the same physical properties. Okay, so think about chemical properties as being like being able to ignite, okay, whereas physical properties are more like the color, the texture, the shape, things like that, okay? The air we breathe, most people think, okay, well, it's air, but it's actually composed of nitrogen and oxygen, and surprisingly, it is mostly nitrogen. Okay, so it's about 78% nitrogen and only 21% oxygen. So when people are sick and they get 100% oxygen, they're not getting any of that nitrogen. Okay, now here are some common gases. Hydrogen is a common gas. The blimp, oh my goodness, what was that blimp called? The blimp that caught on fire, the Hindenburg, was filled with hydrogen. The problem was that it caught on fire. The nice thing is that hydrogen is lighter than air, which is why you would fill a blimp with it and it would float. Helium, that would be what you fill in your balloons. Okay, here's some other ones that you might not have thought about. Hydrogen cyanide, hydrogen chloride, carbon monoxide. Now this one, you know, this is what comes out of your car exhaust, and this one is very poisonous. Carbon dioxide, this is what, when you breathe in oxygen, you breathe out that carbon dioxide. Methane, this is when we use the Bunsen burners, that's the gas that we're using. Nitrous oxide, that is if you've ever been to the dentist and gotten laughing gas, that's it. And ammonia, that's, you know, the gas that comes out of your cleaning type products. All right, let's see. What else about gases? All gases are composed of nonmetals. Okay. This would show their place on the periodic table. They like to expand to fill their container. Again, we said they have no definite volume or shape, so they fill whatever container they're in. Think about blowing up a balloon. It's all the gases are going to be flowing around inside that container. Gases also can be readily compressed. Meaning that you could take that gas and you can squeeze it. They also form homogeneous mixtures. Okay, remember homogeneous means that they're the same, so they're all going to mix together and be the same. Regardless, so they form homogeneous mixtures with each other regardless of the identities or relative properties of the component gases. Okay? And last but not least, the individual molecules are relatively far apart. Oh, I lied. Not least. Last but not least now, the molecules are moving extremely fast. Compared to those in solid, liquids, and gases. Okay, so if you think about a gas, all the molecules are going all around really fast and all over the place, whereas liquids are a little bit more chill, and solids, they're not really moving at all. All right, let's talk about pressure. The pressure of a gas is the force per unit area that the particles in the gas exert on the walls of the container. Okay, pressure is defined as the force over area. Okay, we measure we measure pressure in a couple different units. This is what scientists prefer, is something called pascals. We can also measure pressure in pounds per square inch, and this one's probably the one that you're most familiar with, or PSI. Like if you're going to pump up a basketball or your car tire or your bike tire, those all require a certain amount of PSI, or pounds per square inch. That tells you basically how much gas you want to put in per inch. Okay, and then there's also atmospheric pressure, okay, or ATM, and 1 atmospheric pressure is equal to 14.7 PSI, which is also equal to 101,300 pascals. Now, atmospheric pressure is the amount of pressure that's pushing down on you from the atmosphere, and you're so used to it that you don't even realize it. That's just the way things are. That's the way you live, okay? Now, talking here, the gas in an inflated balloon exerts pressure on the inside of the surface of the balloon, okay? So the inside has got some air pressure, and the outside also has some air pressure. And we'll talk more about this later. We can measure pressure in a couple of different ways, okay? The first way to measure pressure is something called a barometer, and this is designed by an Italian scientist, Evangelista Torricelli. Let me try to say this in my best Italian accent. Evangelista Torricelli. How was that? I have 0% Italian in me. All right, this was the first instrument to measure pressure exerted by the atmosphere. Okay, so basically what happens is the atmosphere pushes down the mercury and the mercury raises up. Okay, as the pressure changes, my mom always gets headaches when the pressure changes, or when you can feel a change in the atmosphere, like a storm is coming in. You might see that the pressure would change here, okay, or this would push down and push up. Now we know that mercury is toxic and they don't use mercury anymore, but back in the day, this is what they used. The next thing you might notice is a pressure gauge. Now this should look familiar to you. Okay, this is a device that can attach to a tire or a tank to measure the pressure. So maybe you're seeing like your tire looks a little flat, you would use one of these, and out the bottom here comes something that measures the pressure. Maybe you put one of these on your bike tire. Anytime that I've gone for a flat tire, they start by using this pressure gauge. The pressure is directly proportional to the number of particles. For example, doubling the number of gas particles doubles the amount of pressure. Okay, so for example, if you've ever pumped up your bike tire, you add gas into your bike tire and you should see that the pressure goes up, okay? Or if your pressure is low, you should see that the pressure goes down. Hope you enjoyed this first bit of information on gases, and I will see you soon. Bye, friends.